Hi. Today we are going to discuss about storage media crisis and the future of storage media. Hard disk drive prices have surged across both retail and enterprise markets due to a combination of unprecedented data center demand and structural supply chain shifts. Key reasons HDD prices have risen. The AI data boom, generative AI models, data lakes, and archival infrastructure require exabytes of continuous storage. Hyperscalers, Google, Microsoft, AWS, Meida, are buying up high-capacity drives in massive bulk quantities directly from factories. Spillover from high SSD costs, NAND flash memory prices skyrocketed due to AI server demand, making high-capacity enterprise SSDs extremely expensive. As a result, data centers pivoted back to mechanical HDDs for bulk, low-cost archival storage, further driving up HDD demand. Build-to-order manufacturing. Following the 2022 to 2023 storage oversupply, major manufacturers, Seagate, Western Digital, Toshiba, shifted to strict build-to-order models and long-term enterprise contracts. With factories running near 100% capacity for contract buyers, fewer drives enter the consumer retail market. Higher manufacturing costs. Modern high-capacity drives rely on expensive technologies like HMR, heat-assisted magnetic recording, multiplatter helium chambers, and rare earth components, raising production baseline costs. When are prices expected to come down? 2026, early 2027, elevated prices are expected to remain high. Enterprise supply commitments continue to absorb most production capacity, leaving retail stock tight. Late 2027 to 2028, gradual relief. Industry analysts forecast prices to begin stabilizing or trending downward around late 2027 to 2028. What will trigger the drop? New NAND fabs coming online. As next-generation flash memory fabrication plants reach full capacity in 2027 to 2028, SSD prices should ease, redirecting storage demand away from HDDs. Matured high-density HDD yields, mass adoption and higher manufacturing yields for 30 TB plus HMR drives will lower the cost per terabyte across all drive tiers. Now, what is the upcoming technology in archival storage? How long will it take to get that into production? The next generation of archival storage is moving toward ultra-durable, high-density media engineered to preserve data for centuries with zero maintenance power. The primary upcoming technologies are ceramic memory, 5D optical glass, and synthetic DNA storage. Pure Storage Blog Everpure Plus 1. Key archival technologies and production timelines. 1. Ceramic on-glass storage, e.g., Cerabyte. The technology uses ultra-fast lasers to print high-density data matrices onto ultra-thin ceramic layers bonded to glass. The resulting material is immune to fire, water, EMP, and radiation, with a lifespan exceeding 5,000 years. Cerabyte Plus 1. Timeline to production, currently in active pilot testing and lab evaluation, including trials with CERN. Commercial enterprise units are targeted to enter initial production between 2026 and 2028. 2. 5D optical glass storage, e.g., Project Silica, S-Photonics. The technology uses femtosecond lasers to encode data inside fused silica glass, creating multi-layered microscopic structures called voxels. A single glass plate can hold several terabytes for over 10,000 years without needing environmental controls. Medium Plus 1. Timeline to production. Core research proofs and high-density reads have been demonstrated. Broad cloud and enterprise data center integration is expected between 2028 and 2030. Medium. 3. Synthetic DNA data storage, e.g., Atlas data storage, biomemory. The technology translates digital binary code into synthetic DNA strands using nucleotide sequences, A, C, G, T. DNA provides extreme volumetric density, capable of housing tens of petabytes per gram, and remains stable for thousands of years. CoinGeek. Timeline to production. Niche commercial offerings and early pilot systems debuted between 2024 and 2026. Scaling write speeds and reducing synthesis costs for mainstream enterprise production is projected for 2028 to 2032. 4. Near-term bridge, HMR hard drives. The technology, heat-assisted magnetic recording, HAMR, uses diode lasers on drive heads to temporarily heat magnetic media, allowing data bits to be packed vastly closer together. Timeline to production, in active production now, 2024 to 2026. HAMR serves as the primary high-capacity bridge before ceramic and glass media fully scale. National Academies of Sciences, Engineering, and Medicine.